Welcome, my dear students in Prep 1. Today, our session is about polygon. We studied before polygons. A polygon is a simple closed line that consists of 3 line segments or more. The polygon is named according to the number of its sides. We studied before polygons. We said that the polygon is a closed shape, consists of only line segments. Okay, it doesn't have any curve, and it should be closed. Here we have another definition, that the polygon is a simple closed line. What do you mean by simple closed line? The simple, it means doesn't cut itself. Okay, so this is a line. Simple, it means it doesn't cut itself. Closed, it should be closed. Consists of 3 line segments or more, not less than 3 line segments, and we name it according to the number of its sides. For example, here I have a triangle. It is a polygon, consists of 3 sides, so this is a triangle. Okay, here we have 4 sides, 1, 2, 3, 4, so we call it quadrilateral. 4 sides, the polygon consists of 4 sides, it is a quadrilateral. Okay, here we have 5 sides, 1, 2, 3, 4, 5. We call this polygon pentagon. Here we have a polygon consists of 6 sides, 1, 2, 3, 4, 5, 6. So we call it hexagon. If the polygon consists of 7 sides, like here, 1, 2, 3, 4, 5, 6, 7, we call it heptagon. So we have quadrilateral, 4 sides, triangle, 3 sides, pentagon, 5 sides, hexagon, 6 sides, heptagon, 7 sides, and finally we have octagon. Octagon consists of 8 sides. Okay. Sorry. So again, the polygon is a closed shape, consists of line segments, 3 or more line segments, and we call or we name it according to the number of sides. Of course, the number of sides is the same as the number of vertices, and the number of vertices also is the same as the number of angles. We studied that before in primary stage. Okay. We have convex polygons and concave polygons. So we have 2 types of polygon, convex and concave. Okay, let's see what is the difference between them. In convex polygon, the measure of each of its interior angle should be less than 180. So the interior angles here should be less than 180. So it can't be reflex angle. This is a convex polygon, and this is the type of polygon we will study this year. Okay. This polygon, for example, is a concave polygon. What do you mean by concave polygon? The measure of one at least of the interior angles greater than 180. Okay, let's clarify here. For example, this is the first type. Here the first type of polygons, which is convex polygon. Each angle here less than 180. But if you look at here, in this polygon, we have an angle here. This angle is a reflex angle. The measure of this angle is greater than 180. So if at least one interior angle, the measure of at least one interior angle is greater than 180, then this polygon is called concave polygon. Oh, but we wanted to study this type of polygons this year. This year we will study the convex polygon, which the measure of each of the interior angles less than 180. Okay. Okay. Sometimes we need to calculate the number of diagonals. We need to calculate the number of diagonals of any polygon. The number of diagonals can be calculated by this rule. The number of diagonal of any polygon can be calculated by this rule. N is the number of sides. n times n minus 3 all over 2. So I'll multiply n times n minus 3 all over 2. Let's see. For example, if the number of sides is 4, it means we have a quadrilateral like here. How many diagonals do we have? We can draw this is the first diagonal and here we have the second diagonal. So the number of diagonals in quadrilateral is 2. 2 diagonals. Okay, let's try to use this definition or this rule. The number of diagonals equals 4. 4 because in here the number of sides is 4. 4 times n minus 3, it means 4 minus 3. 4 minus 3 is 1. Over 2, it will be 2. So the number of diagonals of a quadrilateral is 2 diagonals. For example, if I want to calculate the number of diagonals of another polygon, for example, let's see. For example, hexagon. So n will be 6 times 6 minus 3 is 3. So 6 times 3 over 2. Okay, the number of diagonals will be n, which is 6 here, times n minus 3, it means 6 minus 3, which is 3 over 2, it means 18 over 2 equals to 9, and so on. So if you want to calculate the number of diagonals, you can calculate it by using this rule. Number of sides times number of side minus 3 over 2. Okay, let's continue. I want now to know the summation of measure of interior angles of the polygon. We studied before that the summation of measure of interior angle of triangle is 180 of a triangle. The interior angle of any triangle, the summation of measure of any interior of any triangle, the summation of measure of interior angles is 180 degrees. Okay, we studied that before. Okay, what about the polygons here? A quadrilateral or pentagon or hexagon or heptagon? How can you find the measure of interior angles, the summation of measure of interior angle? Okay, we can divide them to triangles from only one vertex, and then we will multiply by 180. For example, in the quadrilateral, I can draw this line. Okay, so we divide this quadrilateral into 2 triangles. Okay, what does it mean? It means that the summation of measure of angles or interior angles of triangles equals 2 times 180. The number of resulted triangles will be 2. So I'll multiply 2 by 180 equals 360. So the summation of measure of interior angles of quadrilateral is 360. What about pentagon? We can divide it from one vertex. I'll draw lines to divide this pentagon into triangles. We have 3 triangles here. Okay, so I'll multiply 180 times 3. What about hexagon? Also, I'll choose one vertex and I'll draw lines. We have 1, 2, 3, 4. Okay, we have 4 triangles here. So 4 times 180 equals 720. What about heptagon? By the same way, I'll choose a vertex and draw lines from this vertex. Now I have 1, 2, 3, 4, 5 triangles. So I multiply by 5. 180 times 5 equals 900. Okay, so the summation of measure of interior angles of a triangle heptagon is 900, hexagon 720, pentagon 540, and quadrilateral 360. We have a rule. Can you notice that the number of resulted triangles less than the number of sides by 2? 4 minus 2 equals 2, 5 minus 2 equals 3, 6 minus 2 equals 4, 7 minus 2 equals 5. So we have a rule to calculate the summation of measure of interior angles of any polygon. The summation of measure of interior angles of any polygon equals n minus 2 times 180. N minus 2, this is the number of triangles. then I multiply by 180. So this rule is used to calculate the summation of measure of the interior angles of any polygon. Okay, for example, calculate the summation of measure of the interior angles in octagon. Okay, interior angles of octagon. Octagon, it means the number of sides equals 8. It means n equals 8. Then I'll use the rule. It will be 8 minus 2 times 180. It will be 1080 degrees. Okay, so to calculate the summation of measure of interior angle of any polygon, you will use this rule. N is the number of sides minus 2, then multiply the result by 180. Okay, let's continue. Here, for example, we have a polygon. Okay, we have a type of angles which is called exterior angle. The exterior angle of a polygon is the angle included between one side and the extension of the adjacent side. For example, here, look at here. This is the first exterior angle. Okay, it's between this side and the exterior of this adjacent side. This is angle number 1. And here we have angle number 2. By the same way, we have angle number 3 and angle number 4, angle number 5. Okay, I'll draw only one exterior angle from each side, from each extended side, and we notice that the summation of measure of exterior angles of a convex polygon, we said we will study only convex polygon. So the summation of measure of the exterior angles, all the exterior angles of the convex polygon is 360 degrees. So we have a rule to calculate the summation of measure of interior angles of a polygon, which is n minus 2, then multiply the result by 180, where n is the number of sides. The summation of measure of the exterior angle of any polygon is 360. Okay. Now we want to define a type of polygons which is a regular polygon. A regular polygon is a polygon in which all the side length is equal and all angles are equal in measure. So all its sides are equal in length and all its angles are equal in measure. If you have a polygon, for example, like here, regular hexagon, regular here a square, this is a regular quadrilateral, and we have equilateral triangle is a regular triangle, and here we have regular pentagon. Okay, in this case the measure of each interior angle, in this case only we can calculate the measure of each interior angle, not only the summation, the measure of each interior angle, because we said here that all the angles are equal in measure. So I can calculate the summation of measure of interior angles, then divide by the number of sides. So we have a new rule. If you want to calculate the measure of each interior angle in a polygon, n minus 2 times 180 over n. So the summation of measure of interior angles, this is the rule of the summation of measure of interior angles. Then I'll divide by n to get each interior angle. So now we have a new rule to calculate the summation of measure of each interior angle of any polygon, which is n minus 2 times 180 over n. n is the number of sides. Also, we can calculate the number of sides by dividing 360 over 180 minus the measure of interior angle, the measure of one interior angle. This rule used only in regular polygons. So in regular polygons, we can calculate the number of sides by the number of sides, which is n, by dividing 360 by 180 minus the measure of interior angle. Okay, that's all about our session today. Next session we will talk about the parallelogram and its properties and also its special cases. Thank you very much for watching. See you next session. Goodbye.